Hi everyone, so today is the second devlog for my game, The Guardians of Subterrania, and today it's a very specific thing that I want to talk about, which was the Rewired input system and getting that working cross-platform for the 3 different platforms that I need to support. So when we look at my ticket, now it's over in the completed row because I wrapped it up this morning and I thought it would be a good time to do a post-mortem and talk just a quick bit about this. But the ticket was to validate that the Rewired input system would work cross-platform and to create this, I wrote QA system, but it was really this tester component or class that would read all of the inputs from the 3 primary platforms. And those platforms are the Atari store and Atari VCS hardware. So the controller on that, the modern controller is the controller that I'm supporting right now. There may or may not be enough hardware buttons on the classic controller to support it. If there's parity for the amount of buttons and inputs to the modern controller and the classic controller, then yes, I will support it. But the classic controller is the joystick that you hold like this, like the old school 2600 or 7800 Atari. And then the modern Atari controller is like this. It's very much like an Xbox One gamepad. Dual analog sticks, same button layouts. There is very good parity to that. And then, of course, Microsoft Store and the Xbox controller. I found that the controls pretty much map the same way from the 360 to the Xbox One S controller wireless that I have here. So I am hardware testing as well. But for the immediate dev on my PC, I'm just using this wired Xbox 360 controller. So this was the requirements. They're done. And to get started on this, I needed to go into the GDD here. Now this GDD is awesome. It took me a little while to come up with it, a few weeks of outlining every corner, nook and cranny of this game that I thought I would forget or, was a great idea. And I iterated on those ideas. It is not completely done. There is a lot of aesthetic direction and concept art stuff that still needs to be done, but there's placeholder boxes in there for that stuff. But what we're looking for today, well, first off, let's talk about Guardians of Subterrania for one moment. So this is a 3D game. It is a fantasy action adventure with a little bit of roguelite features in this. And basically you're going to be fighting against these evil forces in a subterranean world. And it's all about combat and exploration. And some of the other games that I could think of that it's probably like would be maybe The Witcher, or even Red Dead Redemption, where there is a bit of a focus, like in RPG games, to stat up your character's experience level, magical ability, and stuff like that. So there are 2 aspects in this game. There is melee combat based on sword and sorcery genre stuff with metal weapons, wooden weapons, and body armor. And then there's a magical element. There's less of a focus on the magical side. It's not like you'll be able to play as a wizard or a sorcerer, but you should be able to harness magic from within the world to augment your melee abilities. And there's a little bit of the story here for this. And again, here's where I talk about the sword and sorcery subgenre, just so folks know that this isn't sci-fi fantasy. This is not dark fantasy. And then all kinds of stuff, all the stuff that you would expect, the platforms and all of that. I'm going to go back up because today's focus is going to be on the player input mappings. So this is where I laid out what I expected just the player. Now these are not mappings for the user interface, so pausing in to the UI like a game manager with the user interface, or navigating through a menu system with a controller or a keyboard and touching buttons and button events. This is just for the player controls and movement that we focused on for this ticket here. So it's hard to get it all on screen and everything here, but just basically the basic movement: jumping, sprinting, crouching, ranged attacks, primary attacks, the ability to block, pull up your map, pull up your inventory, interact with things like chests or interactable items. You need to press a key to trigger something. And then I mapped out what they should be mapped to hardware-wise for keyboard and mice, and then generally what they should be mapped to for any generic controller or an Xbox controller or an Atari modern controller. And luckily there was parity across all of these gamepad controllers, Logitech gamepad as well, that just worked with these button mappings. So let's go back over into Unity and we'll look at this scene here. This is my Windows project. I'm rendering in Universal Render Pipeline, and this is just, ignore this rock. This rock right here is just a placeholder element in the scene so that I have a scene to debug my input. And the rock was in there as a validation of the shader system that I'm using, just to make sure that this shader would render properly and animate properly on the Atari VCS, on the Windows desktop, and on the Xbox One S. So it was a render validation thing that I just left there. So Rewired, installed through the Unity Package Manager as a purchased, I typed that wrong, as a purchased asset. Right there, you import it, and I think if we click View in Asset Store, we can see that it's $45. It has quite a few advantages over Unity's new input system. So it has presets and supports a wide variety of controllers, joysticks, steering wheels, and things like that. And all of the hardware button input mappings propagated from those presets for those specific hardware devices. It's crazy. It's crazy good. It works a lot like Unity's new input system, almost identical to the idea of it. It's just more extensive, and it supports a wider variety of hardware devices. I think the thing is like Rewired had come out in 2016 or so, I think, that long ago. And it was around before Unity's new input system was a thing. But Unity's new input system adopted this same methodology. So became slightly redundant, but this is really robust, and you'll see. So I've imported in the Unity package. That's where it is on the asset store, and it'll bring in this Rewired folder. And I've created a Rewired Input Manager prefab, and if we click the Launch Rewired Editor here, we'll get this editor, and it's just a window that I've docked up here in my Unity editor. And some of the core things that you need to do right off the bat, there are some global settings for all of your different platforms, and it's crazy. Look at all these different platforms that have presets and settings, and this is just much more detailed than Unity's input system. And Unity's input system does work for games of like a more limited scope or smaller nature. Like if you're just an indie dev with a really small team making a mobile game or something, this is way overkill. But if you're trying to multi-support several hardware vendor platforms at the same time, this is probably something that's going to be powerful for you. So you'll create a player. You'll get the system default thing, but you create a player. The player comes with basically joystick maps, keyboard maps, mouse maps, and then your custom controllers, which is really interesting because you can create custom information in there for button ID mappings on like controllers that no one's ever even heard of, which is awesome. Joystick maps are basically game pads. I wish they would have renamed this, but it's talking about like the analog sticks on game pads. So that's what that is. That will cover all of your game pads, keyboards, mice, and custom controllers. So you are covered in any potential hardware scenario. I haven't messed with categories or layouts at all. It's only been a couple of days that I've been playing around with Rewired and got that work done and validated it. But it's joystick maps, keyboard maps, and mouse maps that have been really pivotal. So the joystick maps over here, if we take a look on this left side, and you can kind of see this, this is crazy. We've got button mappings for like the Nintendo 64 and GameCube. This is probably for emulators because the emulation is a big thing. So if you want to build something out of Unity that can run through emulation and play Nintendo 64, but emulate those same button mappings, there you go. It's crazy. It's got all the Logitech and Mad Cat stuff, and it's just in the SciTech stuff. It's insane. Switch, all of the newer consoles and stuff like that too. I just use the joystick port for the Xbox controllers, and if you create defaults here on your elements of the joystick maps, it'll propagate. It auto-propagated all of these hardware buttons from the Xbox controller. Just automatically gave me the whole list of all of them. Like we can see here, B is unused. Now, if they have something in parentheses next to them, it means they're assigned to an action. So how did we get all these actions? After we create our player, we go over here and create actions, and you can give it a category. I haven't seen a need to create different categories for my project, but I definitely could see like maybe one category is, this could be called player or gameplay, and another one could be called user interface or UI. And then that's where you'd put your button interactions for your UI or something. Really cool. So these are the actions, and you just think about all the things. I needed to go back to my GDD and say, these are all the things the player can do. these will translate to the actions. And that's what these are. So sprinting, crouching, and you just create all of these in here, all of your potential actions that you want, and you'll give them a name over here, and you just type it in. You can give them a descriptive name and like a friendly name for code, and then behind the scenes sort of name. So actions are important. Creating a default player is important. And then you go over to your maps. And so if like I want to map the A button on the Xbox controller to something, the actions will all show up in here that I've created over in the Actions tab, and that's where I mapped A to jump. So if I deselect it, you can see A is unmapped. We'll map it to jump. There we go. For our joysticks, the Xbox 360 controller joystick, we're mapped to jump. And the same thing for keyboard. So default category, if you want to jump, here it is. We map that with the space key. The pull for key press will allow you to press any key on the keyboard and basically remap. And then here are your actions. And I just assigned it in the same way to map. And that allowed me to get those maps in there. And so mouse was also a consideration. So the ability to look around when you're using mouse and keyboard, it's going to be based on the delta or the X and Y movement and up and down, left and right movement of the mouse on the screen. And then the left mouse button and the right mouse buttons will also be different things like attacks. So that was it. That was it. I had all of my inputs, all of my hardware categories and actions that I needed to do for my player, everything mapped. I had my gamepad map, I had my keyboard and my mouse map. I was all set. And so what I needed to do was create some kind of tester. That's called input tester here. Ignore my character script. And when we go in here and take a look at this, I'm going to fix that. So, and the problem with that came from, let's see here, Rewired. Where's their documentation? So when I went and Rewired here and we went through, they got really great documentation. Let me whip on down right here. So this was some boilerplate code right here that you use your include for Rewired. And then they called the class my character, and I forgot to change the name of that class. But this is where you in your code, you access that player ID where I created the player 0. And the reason that you'd have different players is also like if you're doing like a split screen multiplayer or a network multiplayer, you may have different players with different input button mappings too. If I'm thinking around it right. So it allows you to use entirely different button mappings and different functionality on different players, which is cool, different controllers. And then they gave us some boilerplate here on how to write the code to do these things. And what I really loved about Rewired was it used the same nomenclature as the Unity's its old input system used. Get axis, get button, or get button down. And then you reference the string here of the name of that action that you wanted to do. And I'll show you that in the code. So my code right here, this is not production code, so this will not be compiled into a game. This is just a utility tester code for me to validate that input is working. And I just created a bunch of bools. That's why this is real gnarly and hasty. For all of those different buttons that I want to detect and see in the inspector is Unity receiving the input from those hardware devices. And there you go. And I just use the friendly names back over in the Rewired editor. So if we go over here and we look at that, we'll see there are our names. So interact right there, they're under the actions actually. So look vertical, sprint, jump. There's where you give those names that you reference over here in code. We can actually look at them side by side right here. Look horizontal, look vertical, super easy. Get axis and get button. So that allowed me to have a real-time tester ID in here. So like I could just hit play and I can see my mouse delta is already working. So as I swipe around on the screen, we're going towards -1, +1 on the X, up and down. So the look vector to move that camera look around is working. WASD, so there is the D key, there is the A key, W, S. So the hardware is working from the keyboard. That's the mouse and keyboard right there. Jumping, working right there. There's my attack. I think interact was mapped to E. Jumping, what was sprinting? Shift, crouching, Blocking, I can't remember what grab was. R, okay, cycle. C for cycling through items or weapons. Attacking. I don't remember what blocking was. We'll get there. But the interesting thing is I just pick up the Xbox controller and, oh, shucks. Well, I can't demo it in the video because I am not plugged into the Xbox controller right now. I have plugged in the Atari VCS controller. So what we can do is demo the Atari VCS controller. So I'm going to go over to my Linux project. And here's the great thing. This is something I should back up and talk about real quick. So I have a Windows project, and that is this project that we have open. And then I have a Linux project that now I have open. And they're sharing packages and they're sharing content. So as an example of this, they're two separate packages. But to avoid storing redundant content across different packages, I'm using Unity's package manager here, and I'll show you how that works. Let's show in Explorer. Open up the manifest JSON here under your packages folder, and we'll take a look at that. And we'll see up here in our dependencies, right here is a file path for a package that I created. Now, Cold Coffee Software is what I call myself. That is my pseudonym. And then shared content is the name of that folder there, that package. And then this is its location. It's important that this location is a relative file path and not an absolute file path with like drive names to your hard drive and stuff. So that when you want to commit this to source control and GitHub, which this project is in source control and GitHub, none of that breaks when someone else grabs your repo on another computer. So to demonstrate this, we have a folder here called shared content, and that is exactly what you saw in that manifest. If I go in here actually real quick in the shared one, here's a package.json. So any folder that you want to share, you'll use a package.json in it. You will give it a package name, give it some versioning number, just some semantic information and data here, like some of this stuff you don't even need. Like you can see keywords I don't even need. And that will be all of the information that the manifest.json needs to let it know that, hey, there's a package here. And for the time being, the only things I'm really sharing across the two projects, or the three projects, the Windows project, the Linux project, and the Xbox project are just rock, meshes, and materials. But you can share scripts, you can share prefabs, you can share all kinds of stuff. So I'm in the Linux project right now. I can just color this like a gaudy green or yellow or something. I'll hit save so that we write those meta files in the package. Save project. Let's go over to the Windows project. And there we go. We notice in the Windows project now that that item has shifted green because it's sharing that rock content. So we don't need to store the rock content in two different places. And then we can do something like that. And again, we're in the Windows project now, so it shuttles both ways. We'll save our project, go back to the Linux project, and boom, it's turned red. Let's Z back on that so it goes back to its default color. Let's save project to write those meta files. We'll go back to the Windows project, it's updated. So if you can see the power of this, you can drop prefabs in here, you can drop scripts in here so that you don't need to copy paste things between all these different projects. In essence, the Unity project itself becomes a data container of attributes for that hardware platform. So you can have a lot of very specific platform settings. And I think that's what Unity intended to do when they created like those platform specific overrides and then the ability to go up in here and switch platforms here. But that can be a real pain and a real beast as you recompile like a bunch of assets switching between Linux or Android or something like that. There can be a lot of unintended changes that happen to the assets behind the scenes doing that too. So for me, my decision being a lone developer who hires contractors to assist with art and some bits, like I'm the primary owner of all of this, the repository. Now I've hired numerous story writers and artists to help, but they're not in my Unity project. I am the one that owns the Unity projects and is responsible for all of the architecture and fully responsible for the integration. So if this system makes sense for me and works for me, then that's what's important. Now the documentation side of it and that thorough GDD and all of that, that's the stuff that guides external contractors. With that said, let's go over into the Linux project. And what we can do is, this was the exciting thing too, is the input tester in here. I'm going to just hit play. We'll go through. And again, I'm on the Atari VCS modern controller. We can see that that is the left analog stick. We are getting the proper X and Y coordinates. This would move a player at this point. I could just plug these values into a character controller and it would work. The look vector. This is to move the camera around and look around the world. Works, 100%. Cycling, interacting, all of these different buttons and bumpers all work. I'm trying to hold them down all at the same time. I've just about got every single one, but they all work. And this is the Atari VCS controller. This is using the exact same Rewired input manager that I use in the Windows. It's shared. The prefab is shared. So that is really great. This utility class input tester script, however, because it's such a small utility class and it's never going into the game as production code, it's hastily written and gnarly, and it is not shared in the package because I just don't, I'm not going to share utility class stuff. That can be individualized in the project. So that will help prevent redundancies and any work or downtime copy and pasting things. And you can see that we have immediate cross-platform support. I don't need keyboard support, but right now I'm on the keyboard in the Linux project, and I'm on a Windows PC running Windows 10 right now, but the keyboard also works as a side effect of this too. But you can go into your Rewired editor prefab here in the global settings, and you can, like if we go to Linux here, we can disable mouse and keyboard right here on Linux. So we might not want that to be a thing. Then again, there might be something where the user will use a keyboard or something with the Atari VCS box. I'm unsure, so I might not disable it right off the bat. But this video has gone a ways over, but just super exciting that I got Atari VCS controller support right out of the box. And kudos to Atari themselves. Dave over at Atari there has been absolutely amazing at interfacing with me and getting me the NDA and getting me all of the resources on the Atari, the Discord that they use to help developers, and getting me these custom controller hardware maps and attributes, because this is what allowed Rewired to work with these Atari controllers right out of the box. And I love it. I think after this project is done, I may work on some kind of framework that's going to be free and open source and will allow this Atari controller support in a much simpler fashion for the Unity input manager. Atari did send over some stuff to work with the Unity input manager, but it was quite a few classes and things that you needed to do. And I think it just needs to get to a point where it just works out of the box. But this is not any fault of Atari's. This just has to do somewhat with the differences between Linux and Windows and Unity's own support for different controller types in their input manager, right? It's falling short in a couple of spots. So anyway, I'm going to end that devlog now, and thank you all for watching.